Hear me? Okay. Yeah, so I'm a machine learning engineer at Spotify, and I work in the department that deals with monetizing the product. So I'll talk a little bit more about that. So I think, as was just alluded to, Spotify is a really popular product. You know, we have a lot of users. We have a lot of subscribers. That's one way that the product is monetized. But then we also have a lot of people, millions of people, who are enjoying our free product. And that is monetized via advertising. So the company's revenue mission, that's the department that I'm part of, when we think about how we monetize this product, we really want to prioritize the user experience first. So we don't want you to, be using Spotify free and be annoyed with the ads. We really want you to kind of enjoy the ads as part of the experience, that these ads are relevant to you, that these ads are kind of interesting, innovative products in themselves. And part of how we accomplish that is by ad targeting. So anybody who is, I think, involved in digital advertising is familiar with the idea of targeting. Basically, you want to give people the kind of ads for things that they're interested in, and not things that they have no interest in ever buying, because that's a bad experience for the user. And it's also a really bad experience for our other clients, who are the advertisers, the businesses who come to us and count on us to be able to reach people and tell them about their products. So for both sides of that equation, it's really important for us to do good targeting. And one of the ways we can do this is with, we can do this in ways that are kind of more commonly used. So this is like maybe thinking about who the user is as a person, like demographic kind of information. That's pretty common. But then, of course, being a streaming music platform, we have lots of other information that other platforms don't have. We have all this information about what the user likes in terms of their music, what they've listened to in the past, what they're listening to now, how those preferences have changed over time. And we also know kind of, their habits about when they listen and how they listen. So I'm going to focus on this what they're listening to part. Specifically, I'm going to talk about using user-generated playlists to target for ads. And we have, I think it said on the previous slide, we have over 2 billion, or no, it says on the next slide. We have over 2 billion playlists that we have to work with in order to do this. So this is a really rich data set. It's a lot of information that we can use to leverage. And we want to do this to kind of identify context that the user might be in, moods that the user might be feeling at the time. So maybe you have a playlist that is like your relaxation playlist that takes you to your happy place, and you wouldn't want to get like a really kind of jarring ad or an ad for a very active product or something during that time. We want to kind of target towards like habits you might have, like maybe you go for a daily run, and you would be particularly interested in hearing like a Nike ad at that time or something like that. So the idea with this is that we have information related to these user-generated playlists in order to reach users and thereby satisfy them and also satisfy advertisers. So there are kind of two approaches that we use to do this. One is a deterministic approach, and then one is a probabilistic approach that uses machine learning. And then I've just kind of shown some examples here of like categories that we might, you might see ads related to. So I'll talk first about the deterministic targeting, because this is what actually forms the training set for the probabilistic model. So our deterministic targeting, it's very simple. It's a rules-based sort of pipeline that we run daily. So basically we use this, it's really cool. It's called Shio. It's Google Cloud Data Flow, but it's internally built API for that in Scala. So if you've used something like Spark, or if you've coded in Scala in general, it provides kind of a really nice experience for using data flow. We use that for a lot of our pipelines, this one included. And basically, we process playlists that have been played sometime within the past 30 days. So we're only looking, not at your playlist that you made just for your cousin's wedding that you were responsible for the music and you're never going to play it again. The idea is that these are really active playlists that are a part of our users' lives. And we have some other selection criteria involved too, and do some kind of processing of the titles and descriptions and things like that. And so then we just used a rule-based approach based on like word matching in order to tag the playlist with different categories that are of interest to advertisers. So again, these are things like, this is my chill out playlist, this is my running playlist. Also some things that are kind of related to who you are, like, you know, maybe this is a baby playlist or a kid's playlist. So the idea is that we then would end up with this data set of deterministically tagged playlists. So we would have like a unique identifier for a playlist, and here's just a few examples of some playlists that came out through this deterministic process. So like the cool 70s playlist got tagged with 70s and chill. Summer nights got tagged with sleep and summer. So it's it looks fairly reasonable. It's probably not perfect, but part of what we're offering to advertisers with this product is not just, it's not really perfection, it's also control. So because it is rules-based, we can go to advertisers and say, this is exactly what it's doing, and they have a lot of trust in that, and they feel like, you know, because our business side helped develop that with them, they have some kind of say in how it's working, and they really like that product, so it's very popular, and we like selling it to them. So the only problem with this is that because it is based on rules, we're sort of constrained by how users choose to name their playlist. So if we would come across a playlist that's named in such a way that is sort of ambiguous to our rules engine, maybe we could come up with like a really complicated set of rules that would catch all these different edge cases. But I think, as probably everybody knows, once you start getting really complicated with your rules, that's when you've hit a really perfect time to use machine learning instead. So if your rules are getting, like if your rule book is the size at which you could like do violence with it, you should probably use machine learning instead of having a big rule book. So yeah, this is an example where this playlist title, if a human looks at it, you know what that means. You understand that this is like a sleeping playlist. But to come up with just like a set of rules that encodes that is kind of complicated. So if you have like this deterministic approach, it's just going to miss that. So this is just one example of where we're seeing like a lost opportunity, and we want to recover that with machine learning. So this is where the probabilistic targeting comes into play. So this is a separate pipeline. It's actually a kind of complex series of pipelines. It's an entire machine learning system. And it starts with these deterministically labeled playlists. So that data set that I showed you where, you know, you have a playlist that is unique, has a unique identifier and a name, and it has that set of labels. Remember, the goal here is not necessarily to do better than that deterministic product because it's something that people really like buying. The goal here is to extend that product so that we can sell more of something that people like to purchase. So that's what we use as kind of a ground truth training data. And that data is then appended with playlist features, which I'll talk more about a little bit later. And then some downsampling is done and some conversion of this into binary outcome data sets corresponding to one for each category. So this is just illustrated using 3 categories. There's something around 40 of them. And it's just a logistic regression model that's used. A lot of what gets complicated with machine learning in production is not necessarily using like a fancy model, but figuring out like the infrastructure around the model, figuring out which model you should use that will satisfy your, your business case. So for example, here, what was actually asked of us from the product side was to have something that they didn't care about like ranking probabilistic labels. They just wanted to make sure that any probabilistic label that could be applicable was applied. They wanted to have more than one label per playlist, which, if you think about it, that makes sense that some of these categories are overlapping or kind of broad. You might have a playlist that satisfies different needs. So, using that in mind, I decided that the best approach was to kind of train a different model for each category. So the training is done weekly, and then the prediction step is done daily, where actually an outcome probability is given for the playlist and label pair. And then some metrics are constructed and used, to threshold and decide which of these probabilistic outcomes is decided as ultimately being tagged with the playlist category label and which ones aren't. So that's just a visualization of the system. And when I talk about data stores here, I think it's pretty well known that at Spotify we are using Google Cloud services. So we use BigQuery a lot when we need to store things in ways that that need to be accessed also by a human. So like if I would want to be able to check on something to get some numbers and give them to somebody in product, I would choose to store something in BigQuery. If I didn't really care about being able to access that information myself, I would probably store it in just like the Google Cloud services, where it's usually we store things in Avro format. Okay, so in this model that I've shown you here, where this binary classifier is used basically to distinguish whether something has a label or doesn't have a given label, there's kind of a key modeling assumption that's being used. So the key modeling assumption is that if I consider some feature space, and I haven't specified what the feature space is yet, but if I'm just thinking about some feature space that describes these playlists, I'm assuming that I actually can come up with a good decision boundary that allows me to separate category from not category. So here I could separate like the chill playlist from the not chill playlist. And this is kind of like a really nice, perfect illustration. In practice, when you have like a binary classifier, very often you see that it's not going to be perfect. You might end up with something on the wrong side of the line from time to time. But in general, I'm making the assumption that given my feature space, I can draw a boundary like this that's going to do a pretty good job. And that way, then, when I have data coming in that I'm going to want to score, so this is like, I've trained my model, and now I've got a whole batch of new playlists coming in, and I want to make actually some decision about are these playlists chill or not. I can apply my decision boundary, and I can make a decision that way and see if this new data, what to do with it, how to understand what it is. So the important thing here, there are kind of differences between classifiers. You can come up with like kind of a fancy model. You can get really fancy with binary classification, but logistic regression is really pretty darn good as long as you put good things into it. So a key thing here is really kind of coming up with good features. So defining this space in such a way that you can do this thing that I've just said. So let's talk about the features a little bit. So the features used here, they're features, probably not surprisingly, related to music. So these are basically encoding playlist similarity. So if I have a playlist that I've made and you've got a playlist that you've made, I want to have some way of saying whether my playlist is kind of similar to your playlist, because the idea could be that like if you have tagged your playlist in such a way that's, maybe that's how you decide to name your playlist, you're really descriptive, and I know that that's like your running playlist, and I just name mine playlist 1, but it's really similar, then maybe that's a good feature to use, that this is similar to your already labeled playlist. So the way that these features are constructed is by looking at track similarity, because a playlist is made up of multiple tracks. And basically what's done is to just come up with like a track cooccurrence matrix. So this is very similar to like natural language processing methods, if anybody's familiar with those, using like word cooccurrences in documents. It's very analogous. We look at track cooccurrences across playlists, and this is a really huge matrix because this is going to include all of the tracks in our catalog, and this is not, you don't want to put like a 1,000,000-dimensional vector in your model. You're going to have a bad time. So you have to do some dimensionality reduction, and so we do that with some matrix factorization to reduce the size of the matrix to a manageable level. And then I've just taken these track level vectors that are these reduced dimensionality vectors that encode track similarity, and I've aggregated those across the playlist to produce playlist level features. So these playlist level features that are being used in the model, what they really include is playlist similarity based on track cooccurrence. So you can keep that in mind. And this is what they kind of look like when they get appended then to a data set. So this is just an example. None of these numbers are going to mean anything because these are just coordinates in a vector space. But this is like kind of the data set that I would have then, is to have, again, a unique identifier. I just keep the name there for my own reference if I ever want to look at this, the features, and then the label in the case that it has one. And then once I have these features, I can actually then start talking about modeling. So I generate a training set weekly, again, for each category. And this comes from the deterministically tagged playlist. And like I referenced before, these are kind of converted then into binary outcomes. So if I had something like, you know, a bunch of playlists with lots of different categories, but what I'm thinking about is the running category, I would then separate these all into whether this is running or not running. And so these not running playlists could also include playlists that have no deterministically assigned category. I don't include those in the training data set because those are what I actually want to score. Those are the things that I want to make predictions for once I come up with a good model. Because there are something like 40 categories, positive examples for any given label are much rarer than negative ones. So since there's some sampling done here, there's downsampling used, and we store the downsampling ratio so that we can then correct the intercept of the logistic regression model later. For the modeling approach itself, we're just using cross-validated logistic regression and scikit-learn. And then the coefficients of the model are stored in a BigQuery table where they can then be picked up by the SHIO pipeline and used to make predictions daily. Yeah, so then this is what ends up coming out of like the prediction step. I would have for each playlist, I would have all of the labels being predicted and some kind of outcome prediction, which is a probabilistic outcome as the daily prediction. So then, since I have this number for all categories and for all playlists, that's not the desired result. I want these to make sense, so I have to have some evaluation criteria and make some kind of cutoffs. So since this is a binary classifier, and I'm assuming that the deterministic product is a ground truth, because remember, I'm not necessarily, we want the product to be accurate, but what we really want is that it scales up the deterministic product, which has already been, advertisers consider that accurate enough, they have confidence in it, they want to buy it. So since that's the goal, use that as a ground truth, and you can construct this confusion matrix from all of the outcomes, and you can use any kind of, metric that you're interested in that corresponds to a binary classifier. So like the ROC curve is a common thing to look at, but I find that a lot of these get kind of complicated to explain to people who are on the product side. And so I like using, it's just, if you don't spend all your time thinking about these things, there's no reason why you should really understand them. I like to use the balanced accuracy in this case because, like I said, the classes are in balance, so you have to use some kind of metric that accounts for that. Otherwise, you're just going to think that you're right all the time. And accuracy is it's a concept that people understand sort of intuitively. So I use that and threshold on that to come up with actually deciding whether the label gets appended to that playlist or not. And then it ends up being, once I make that decision about whether the probabilistic label applies or not, then this gets stored in a system. So we right now use DFP as our system for managing the sales of ads. So this is what our salespeople can then go in and look, and they can see, this advertiser wants playlists with this category. What kind of inventory do I have? So this kind of completes the entire chain for scaling up our deterministic product, which is the goal with this. So that's kind of it. If anybody has any questions, I will be happy to try and answer them. Hi.
Is your umbrella I'm just curious, is your ad management internal, and so how do you manage to scale that?
Is there ad management in?
Right, the platform for serving the actual ads.
Right, so our ad serving platform right now is DFP, which I think is a pretty commonly used one in advertising. We're right now in the process of I think it's been, you might have even seen Facebook ads for it or something. We now have something called Ad Studio, which is kind of like our own in-house sort of thing. But we're still using DFP for a lot of things. So for like our managed ad sales, like where salespeople are selling to really big clients, they still tend to use that. We anticipate that we'll have that solution around for a while. So.
Right. First of all,
Hi.
very nice presentation.
Thank you.
And I like your choice in terms of logistic regression. But I'm interested in terms of, did you look at support vector machines or
Nope.
random forest? And
No.
okay.
No. I have sort of a bias towards parametric models. I think that when they work well enough, especially if you have, like, non-parametric models can be really nice if you have kind of a not very well understood relationship between your features and your response, and if you have a whole lot of data with which to train. But they're also, even though you can get sort of better performance because they learn that relationship, they're kind of hard to encode. So like this step of model serialization, this is not necessarily like the simplest problem. So this is what I was kind of referring to when I said that when it comes to doing production level machine learning in practice, the hard questions are often not those of, well, can I come up with like a model that gives me just a little bit better performance? They're often things like, well, okay, I made this model, how do I persist it and then store it in such a way that my system can read it and then make predictions and do all of this, within a time that I find acceptable. So, simpler models, parametric models like logistic regression, linear regression, they make that easier. So I think probably my whole team have kind of a bias towards trying that first. And then if it doesn't work, or if you've gotten to the point where you've already done that and you need to try new things, you want to go for that extra point whatever percent, it's going to make a difference, then try the more complex thing. I always like to go simple first and then more complex second. I don't like to start complex. So, yeah. Yes.
My question is, if you guys did like campaign performance, probabilistic targeting versus what like in this kind of thing to see what kind of leads created?
Yeah. So right now, there hasn't been anything like that because right now the first goal was to just scale up this product specifically. There are things that can be done to probably improve this model. So like I said, one thing to keep in mind is that the features that go in, the better they are, the better the model's going to do. So if I want to design some new features to use in this model, that's definitely something I would try, is to try and compare the model performance before after adding the new features. If I wanted to try some different modeling approach, saying that like, okay, this is kind of doing okay, but it's just not doing well enough. Now I need to go kind of more complex, then yeah, something like an A/B test is a good way to understand whether I should make a decision to change my current approach. But since this was just a first pass, it was really the case that anything was going to be better than nothing. So that's kind of nice. You can't fail. But yeah, that's definitely something that we do regularly. We do a lot of A/B testing at Spotify. So.
Hi, thank you for the presentation.
Sure.
Good question. I recently read Spotify recent product how publishers better create self-service. It says.
Yeah.
What's leading to that?
So that's the Ad Studio project or product that I mentioned. So yeah, the idea there is that it's self-serve and it kind of increases the range of customers that we can accept. So until recently, all of our business has been direct sold. And we have a great sales team, they do a great job, but when you have people doing that, then you only can get so much scale. So this allows us to have a larger range of people advertising on the platform. This, I believe, so this is incorporated, we are selling this directly. I don't think it's yet incorporated in Ad Studio, but if it's not, it will be very soon. So it's, yeah, it is in production, but I don't think it's in that product yet. So that product just was released very recently, so they're always making it better. Yeah. Who am I? Okay. Yeah. Sure.
Yeah, I just have a question about the ML pipeline.
Sure.
In one of the slides, you talk about how that was set up, how was the pipeline designed, or some of the key considerations that you guys actually looked into to design that pipeline for the product.
Yeah, so one consideration was, I think I kind of alluded to this, but understanding what they actually wanted the model to do. So at first I thought that what they would want is to have some kind of ranked list of the tags that might apply, so that this one is first a running playlist, and secondly maybe it's a workout playlist, or something like that. But it turns out that they actually really didn't want that, because they didn't have their way of consuming this. It would just be extra information for them that they didn't need. What they really wanted to have was just a list of any labels that applied to this playlist with some certain amount of certainty. They were very willing to work with me to kind of understand what that would mean. So this is again coming to the question of which metric you use, and something like accuracy is something that people have kind of a nice intuitive understanding. So we were able to work with them and come up with a threshold that they were comfortable with, and just saying, okay, any of these models that then passes this accuracy threshold, we go ahead and use that label. So this approach of using like several logistic regression models, right now it's kind of a simple approach because there aren't that many category labels. There's something around 40. If we were to like really explode the number of category labels, then it might be a different sort of game that we're talking about. But given the conditions of the problem, it just seemed like this is something we've done before. We've done production logistic regression. We kind of have a preference for models like that are simple, and so we have already like code written up that we can reuse, pipelines that are also doing that we can look at and sort of duplicate and do quickly. We are scaling up the machine learning efforts, but right now it's, we're very much in the phase where we're not like a Facebook or something where it's maybe about perfecting what you have and getting a little bit extra lift. Like there's still a lot of like, let's turn out this product, let's make sure it does a good job, but let's get it going and get it working and then move on to the next thing. So we're always kind of operating with that constraint right now.
So when you do the matrix authorization, you basically have a representation of how many dimensions does music have and how many genres does music have. So I'm always curious, how many dimensions does music have?
Well, so the dimension of the track cooccurrence matrix is just the size of our catalog. So there are some kind of basic constraints put in there. I'm actually not that familiar with them because the people who produce that data set are the ones who are really involved with music recommendations. And that data set gets used for a lot of different things at Spotify. So it gets used for recommendations on several different fronts. It gets used for monetization models like this one. But it doesn't so much involve things like genres. This specific part, it's really just about encoding track similarity in a specific way based on cooccurrence and playlists. It's really analogous to like treating words in documents, so where the playlists would be the documents and the tracks would be the words. So.
I was just wondering, in your work, is there anything that made the most impact on like ad revenue or like click-through rates?
So that's not something that with this product we were really concerned with. There are different kinds of ad formats that we use, and this is a very specific ad format. So it's only served with playlists, and how it works is that the advertiser would decide that they want to like sponsor your playlist. So if they've decided that, okay, maybe like I said before, Nike comes in. This is a hypothetical example. I actually have no idea who buys these things. Maybe they come in and they say, I want to purchase inventory for like running playlists, and then the salesperson would say, oh, we have this many, and it's not a product that is like the ones we sell through our ad server where we kind of think about like click-through rates and stuff like that. It's really like its own very specific product, and there's kind of a limited specific market for it. So certain brands are interested in certain categories and not really in others. This is my first time working in digital advertising, so I had worked at Spotify for about a year in another department, and so I'm also still learning a lot about it. But what I've seen is that the whole idea of how effective something actually is, that's kind of a new thing, that advertisers don't, I mean, I don't want to say they don't care, but there's not a whole lot of measurement around it in the industry in general. So it seemed like this was a product that really, they were comfortable with having a lot of working together with our business team in designing the deterministic product. And once we told them, okay, you like this, you like what we have, we can scale it up, that they were comfortable with that. I don't know if that's always going to be the case in the future, but for now, this is the parameters that we've designed this around. So.
Thank you very much.